So what we're going to talk about now is basically how the electrons are arranged in an atom. And what you'll find is that the electrons, and this is a very simple description, it's a bit more complicated, but basically what you'll find is that the electrons are arranged in what are known as energy levels, right? So basically we have a situation where you have different energy levels, and the energy levels that the electrons will occupy are according to their proximity to the nucleus. So the lowest energy level would be the one that's closest to the nucleus. Then we have the second energy level, then the third, and so on. And they're designated by this value n. There's a special name for this value here. It's called a principal quantum number, but you don't need to know that. And n can have values of pretty much any integer up to and including infinity. All right. So you have n equal 1 energy level, which is closest to the nucleus down here. You have the n equal 2 energy level, then n equal 3, n equal 4, n equal 5, and so on and so forth. And you'll notice here that as you go up in the energy of the energy levels, the energy gap between successive energy levels decreases. So this gap is the largest gap here between n equal 1 and n equal 2. And then this gap here is smaller, and so on as you go up. All right? Now, another thing you need to realize is that there is some limitation as to the number of electrons that can occupy each energy level, right? And that's what this table here is all about. So this is basically the energy level and the maximum number of electrons that can occupy each energy level. Now, for the first energy level, for the n equal 1, oh, by the way, this formula here basically helps you to determine the maximum number of electrons that can occupy each energy level, 2n squared, where n is equal to 1, 2, 3, etc., right? So for n equal 1, then the maximum number of electrons that can occupy that energy level would be 2 times 1 squared, which is 2. For n equal 2, the maximum number of electrons that can occupy that energy level is 2 times 2 squared, which is 8. And then for n equal 3, the maximum number of electrons that can occupy that energy level is 2 times 3 squared, which is equal to 18. And I'm quite sure you're able to calculate the other numbers of electrons maximum that can occupy the higher energy level based on that formula. All right? So, in terms of how the electrons are arranged, basically what you start to do in deciding where the electrons go for different elements is that, well, firstly, you'd have to consult the periodic table to determine the atomic number, which is the number of protons, which for a neutral atom would be equal to the number of electrons. So basically, the first 2 electrons would go in the first energy level, and then the next 8 will go into the second energy level. And then what you'll find is that for the third energy level, 8 more electrons will go into that energy level, and this is up to argon. And then for the fourth energy level, 2 electrons will go into that energy level, right? So basically our limit in terms of determining how the electrons are arranged for our level would be up to calcium, all right? Okay, so you could be asked a question like this. Write the energy level arrangement for each, and they give you these, right? So the first thing I would do, as I said before, is that I would consult the periodic table, and when I do that, I see that nitrogen has an atomic number of 7, right? Which means that there are 7 electrons in a nitrogen atom. So in the first energy level, you're going to have 2 electrons, and then in the next energy level, you're going to have 5 electrons, and that's basically it, all right? In the case of chlorine, the atomic number of chlorine is 17, right? So the first energy level will have 2 electrons, the next energy level will have 8, and then the third energy level will have 7, and that makes up the 17 electrons. And then in the case of potassium, which has an atomic number of 19, the first 2 electrons will go into the first energy level, the next 8 will go into the second energy level, and then another 8 will go into the third energy level. So that means you're left with, let me see here, you have 8 and 8, 16, 18, which means that there's 1 more electron left over, and that will go into the fourth energy level. And that's basically how that is done, all right? So those are the answers right there. So now we're going to talk about the reverse. If you're given the electron arrangement can you identify the element? And it turns out that this is actually easier because all you have to do is add up the total number of electrons in each case and see which element has the corresponding atomic number. So for example, in this case, 2 plus 2 is equal to 4. And when you go to the periodic table, the hydrogen, helium, okay, so when you go to the periodic table, you see that the atomic number, the element that has the atomic number 4 would be beryllium. All right? In this case here, we have 2 plus 8 plus 3, so that's a maximum, or that equals to 13. And the element that has that particular number of electrons would be aluminum. And then finally, in the case of this, where the sum is equal to 9, 2 plus 7 is equal to 9, and the element that has 9 electrons, or an atomic number of 9, would be fluorine, and that's it. All right? So those are the answers for that. Okay, now it's very important that you be able to identify what is called the valence electrons. All right? The valence electrons can be identified if you know what the electronic arrangement is. Now, this is important because, as stated here, the valence electrons basically determine the chemical properties of the elements, and we may get into some discussion of that later on. Now, by definition, the valence electrons are the electrons that are occupying the highest energy level, and they're also related to the group number of the element in the periodic table. So, for example, in the case of phosphorus, if you write down the electron arrangement, which is this right here, you'll see that in the highest energy level, there are 5 valence electrons, all right? So the 5 electrons in the highest energy level would be the valence electrons. And therefore, as a result, phosphorus is in group 5A in the periodic table. So what you'll find is that all elements in group 5A will have 5 valence electrons in their electron arrangement. So here are some other examples. Now, for example, group 2A or group 2, all the elements in group 2A have 2 valence electrons. And you can see that clearly in the valence electron, or I should say the electron arrangement for each of these atoms or these elements in group 2. All right? And that is true for pretty much all the groups in the periodic table. There may be some exception, but what we have here is some representative elements and their group numbers. So we have group 1, 2, 3, and so on. And you'll notice that elements in group 1 has 1 valence electrons, group 2 have 2 valence electrons, and so on and so forth. So that's a pattern that emerges, which shows you the relationship between the electron arrangement and the positions that the respective elements will have based on the electron arrangement in the periodic table. Okay, so here is another learning check exercise. It says state the number of valence electrons for each, and it says oxygen. So basically there are 2 ways you could do this. You could write down the electron arrangement for oxygen, which would be oxygen has 8 electrons total. So therefore the electron arrangement here would be 2 and 6, which means that the answer here would be 6 valence electrons, all right? Another way you could look at it is that you just simply go to the periodic table and look up the group number. And when you do that, you'll see that oxygen is in group 6. So therefore, or 6A, I should say. And therefore, again, we can conclude that the number of valence electrons in the case of the oxygen atom would be 6. Okay, in the case of aluminum, same thing. We could look at it in terms of the electron arrangement. Aluminum has 13 electrons, so therefore this would be the arrangement, which would mean that the number of valence electrons here would be 3. In the case of chlorine, which has an atomic number of 17, which means that the electron arrangement is this, 287, which means that the number of valence electrons in this case would be 7. And that's basically how that is done. All right? Okay, in this case, they're asking, again, to state the number of valence electrons for each. In the case of calcium, this would be the electron arrangement. So therefore, it has 2 valence electrons here. Now, any element in group 6A will have 6 valence electrons, all right? Because the group number tells you that, right? And then now, in the case of tin, now tin is a bit more complex. And I would suggest that in something at this level, you know, the level that this class is at, if you're dealing with elements greater than 20, to answer this question, you simply have to go to the periodic table. If you do that, then you're going to see that 10 has a group number, or belongs to a group, which is numbered 4. So therefore the answer here will be 4. All right? So that's basically how that is done. Okay. Another learning check here. It says for the element with the following electron arrangement: 1, state and identify the number of valence electrons. 2, identify the element. So in the case of the first one, let me go back to my pen here. All right, we have the electron arrangement 285. So that gives you a total of 15 electrons. If you go to the periodic table, well, firstly, to identify the valence electron, you're going to have 5 valence electrons here. And then we look up the atomic number, or the element with the atomic number 15, and you'll see that that is phosphorus, right? In the case of B, where they gave you 2882, the number of valence electrons here will be 2. So there are 2 valence electrons. And the total number of electrons here will be 20, which means that the element that has that corresponding atomic number would be calcium. And then finally, in the case of 27, the total the number of valence electrons here will be 7. And the total number of electrons here will be 9. If you look up the element with the atomic number 9 in the periodic table, you will see that it's fluorine. And that's basically how that is done. All right. The next slide is basically, that's a solution. All right. So this is just answering the questions that I just did. Okay, so I'm going to stop here. The next thing we're going to talk about is what we call electron dot symbols, also known as Lewis symbols. All right. Until next time.